Hello and welcome back to our video series. In this video, we are going to explain to you what is alternating signal. If you want to know what is a alternating signal, and later on you can be able to appreciate why we have alternating signal, you can watch this video till the end to fully understand what is the alternating signal. I will give you some graphical examples, and the definition for each of the component can be found in an alternating signal. Let us define what is alternating signal. The alternating signal is an electrical signal that periodically changes direction and its magnitude. The keynote to take along with the definition of the alternating signal is it is an electrical signal and it is periodically changes the direction and the magnitude. We all know what is a direction. When you go from one place to another, now you are in one direction. Example, if you are traveling from point A to point B, that means you are traveling in one direction, and from point B you are traveling to point A. Now this is the second direction. And now you know that the AC signal, it normally changes direction and it normally changes the magnitude. When we talk about the magnitude in terms of the signal, we are talking about the amplitude. And this amplitude can be represented as a voltage. So when we say it changes the magnitude, that means it normally changes the amplitude or the voltage, and both of these can be done periodically. Unlike in the DC. In the DC, we normally have the voltage source and it is connected to some load. This can represent the load. And from this diagram, if we want to compare with the AC, in a DC, the flow of current is in one direction. That means the signal travels from the source to the load and back to the ground. Now this makes the complete circuit in a DC. And what happens to the magnitude? If the voltage source is equals to 9 volts DC, that means this load is driven by a constant voltage source which have a constant magnitude of 9 volts, and the direction of the current is from the source to the load, and this is in a DC. What happens in the AC? When we have the AC, we can have the load, and in that case from the voltage source, if it is a 9 volts AC, then we say the current will flow in both directions. That means in the forward direction and also in the reverse direction. And because of this, there is a periodic operation that is done in the case of the direction. Now it will cause the magnitude to vary. We will explain some of the key components of the AC so you can be able to understand how the magnitude varies. And it will be 9 volts and minus 9 volts. This represent the AC signal or the alternating signal. To see the comparison for the DC, the direction and the magnitude, we can say the magnitude is constant to drive the load, and the direction, we have only one direction. And when we compare with the AC signal, in terms of the direction, we have two directions of the movement of the current, and the magnitude we have varying, because it will vary from positive 9 to negative 9 volts. There are key components of the AC signal, and I will explain them in order for you to understand step by step. The first component of the AC signal is the amplitude. The second key component is the frequency. The third component is the phase. And four is the waveform. 5 is the DC offset. 6 is the harmonics of the AC signal. And 7 is the root mean square. When we cover all of these components, you will now be able to fully understand the AC signal. The basic comparison between the two I have made mention here. When you understand this, you can be able to compare the type of signal. In a DC, we say the current travels in only one direction, while for the AC, it is back and forth. It is traveling in one direction, and at the same time, it is traveling in another direction periodically. And the magnitude is constant for the DC, and the magnitude is varying for the AC. When you understand this simple explanation, now we will use the AC to understand all of these key components of the AC signal. So after this video, you will be able to appreciate what is the AC signal. In this discussion, I will mostly use the type of AC signal, which is the sinusoidal signal, for explaining all the key components. And in the sinusoidal signal, we have two types. One is the sine signal, and two is the cosine signal. And before I explain the amplitude, I will now talk about the periodic variation of the signal, because the direction and the magnitude, they base on this periodic variation. That means in a periodic variation, it is now describing the voltage or the current, they reverses the direction cyclically. Since I will explain the periodic variation and all these components using a sinusoidal signal, now I will give you the mathematical representation of this signal. And we have Vt is equals to Vp sine 2 pi f t plus theta. And this now represent a sine AC signal. And for the cosine, we can have Vp cos 2 pi ft plus theta. This now represents a cosine AC signal. By looking at this equation now covers all of these key components. Those key components can be found in this mathematical representation. And the Vt is nothing but a function which represent the sine or the cosine signal. So I will use both the sine and the cosine signal throughout the explanation of the alternating signal. In a sine signal, we can rewrite Vt is equivalent to Vp sine 2 pi ft plus theta. Now we will start to look at the key component of the signal. The Vp, which represents the amplitude, and the frequency is represented by the F in the signal, and the theta represents the phase of the signal. And this is the sine AC signal. Now I will draw the waveform, and then we can describe each of these key components, amplitude, frequency, and phase, by corresponding to the waveform. So this is the AC. Let's draw a dotted line. And we can say plus Vp minus Vp, and we can say the period of the signal. Now we define the amplitude. By looking at this figure, we can see that the amplitude is the dotted line across the waveform. And this is the waveform of the sine AC signal. So with this understanding, we can define the amplitude as the maximum value or negative that the signal can reach, and it can be a positive at this point or a negative at this point. That means the maximum amplitude or the voltage. So when we talk about the magnitude, we can refer to the amplitude, and we can refer to the voltage, the magnitude of the voltage. So when someone asks you to find the magnitude, you will always look at the maximum point in which the signal reaches. And the amplitude can be represented in a couple of ways. The amplitude can be represented as a peak voltage with the notation Vp, which means the distance measured from the zero to the maximum in the positive direction. Therefore, the peak voltage or the peak current, IP, that means since it is periodically changing, we can say the Vp is the maximum point where the voltage can reach, and this curve oscillation line represents nothing but the current. So that means the current also reaches this maximum position, or the voltage reaches this maximum position. because when we say AC, we normally say alternating current or alternating voltage. And in most cases, they call it the AC, but it also means the alternating voltage because of the magnitude. And this magnitude can represent the current or the voltage. And in the voltage peak, we can see that the measurement of the peak voltage is from 0 to the voltage maximum of the waveform. Example, if Vp is equals to 240 volts, therefore we can say the Vp is now equals to 240 volts AC. The important term to remember is the peak. That means the highest point in which the signal may reach. The other amplitude representation is the peak to peak amplitude, and the notation is given as the VPP. And this now represents the difference between the maximum value and the minimum value. This minus 240 or the minus VP is the minimum value. When you look at a number plane, this is the positive value to infinity, and this is the minus value to infinity. So in the middle is the 0. When we talk about the mean value will be towards the minus infinity, and it is not 0. And when we talk about the maximum value, then we are talking about the value from 0 to positive infinity. For example, if you have some range of numbers, for example, you have 9, 4, 3, 0, 2, minus 1, minus 9. In this range of values, if we ask to find the max value and the mean value, we can see that the max value will be the 9 and the mean value will be the minus 9 and not the 0, because any number that is increasing in the negative infinity plane will become our mean value. Therefore, in a peak to peak, it is defined as the difference between the max and the mean value. The term difference, when you see the term difference, it is the difference that is in respect with the negative sign. Example, if we have 5 minus 3, we are taking the difference of the 5. So when you want to find the difference between 5 and 3, it will now gives you 2. So the difference of 5 and 3 is 2. Now with this similar idea of the difference, we are now trying to take the difference between this positive and the negative. So we can have the positive, we can have positive VP minus negative VP. That means this is the max value. We take the difference of the max and this is our mean value. Therefore, we should have plus VP plus VP, and it is now giving us 2 VP. So you can appreciate that if they ask you to find the amplitude in a peak voltage, then it is nothing but the VP. And in this example, it will be 240 volts AC. If they ask you a question to find the peak to peak voltage, now it is equivalent to 2 times the VP. And in our example, you have 2 times 240 volts AC. So this is now your peak-to-peak voltage or the amplitude, and this is your voltage peak of this AC sine signal. And you can apply this to a sinusoidal signal such as a sine and a cosine signal. If you like our content, you can kindly click the subscribe button and share this video with your friends so they can also learn what is the alternating signal. And in the next video, we are going to look at the frequency of the AC signal. So with this video, I am fully aware that you can be able to understand the definition of the AC signal, the type of AC signal in terms of the representation of a sinusoidal signal with the mathematical representation, and the first key component that we discuss is the amplitude. And I believe you know what is the amplitude of a signal, and it can be represented in terms of a peak voltage or a peak to peak voltage.